Okay, good. Thank you, Marco. Yeah, welcome together to the weather briefing in the March. And my name is Peter Schmitt from Deutscher Wetterdienst in Langen, in the training center. And I start today, and my colleague Michael Knobelsdorf from Hamburg, from the northern part of Germany, he takes the second part, and he has a special topic about the research vessel Meteor to the expedition. And I start with the actual weather, some introductions you see in the satellite image a little in the background from yesterday, but at first we will start with the usual thing that perhaps please give you a sign where you come from. One moment, please. Okay. So now this was the technique. So I think now you can make a point or a cross where you come from for an overview, or you come from other countries or other continents. Then you have the left part. Okay. Yeah, it's a good, a good area from Scotland, Spain, Finland, and Poland. Also, I think it's Lithuania, and yeah, very good. Thank you. So I will start with the slide from today, from 9 UTC. Yeah, we have a sunny situation, a high pressure in the middle, in the center of Europe. You see it here for 500 HPA, and it's like an omega situation. We have low pressure in eastern part in the Atlantic, and also on the Black Sea, and on the western part in the Atlantic, with showers and with rain. And we have also a frontal zone in northern Europe, Scotland, Norway, eastward. You see here the shower symbols, and we have a lot of clear sky in France and Germany and the Alps. So I think, yeah, one word, sunny. These are the webcams in Germany. Yeah, it's not much to speak about clouds today. Only in the Alp region there are some small. Then the rest is absolutely cloud-free. And these are the maximum temperatures for today. So yeah, the situation, what I said, first time we have mostly in Germany and the countries in the near more than 20 degrees. Also in England, and also warm temperatures in southern Scandinavia. But in the eastern part of Europe, there are the northerly airflow and temperatures below 15 degrees. So it's a little cloudy. I read it in the chat. I think in Belgrade it was also cloudy. So these are the situations from yesterday. I will speak about some interesting satellite images I found yesterday, and it's not it's similar as today. We have the frontal zone with the front here and a low in the Norwegian Sea. So that big high pressure influence, and it's there is a small low in the north of Africa, and it brings a lot of dust outbreak in direction of Spain. You see it later. So these are the two parts. I show some slides. So the situation in the high 300, and you see the isobars, isohypsis, and with a strong gradient in the north. I was interested where is the rest of winter, and there is a lot of snow in Scandinavia, half a meter roundabout, Finland, Norway, but it's very interesting to see the influence of the Gulf Stream, the warm water temperatures. So we have on the coast, also in the near of the North Cape, only some centimeters snow, 2, 3 or 0, but in the inland there is a lot of snow. So this is the natural color RGB, and I have a question to you. Please mark where you think is snow on the ground. I hope you can do it technically. Yes, okay. In Iceland. Yes, in the Alps, the Pyrenees. Yes, in the northern, in the Scandinavia, there looks also some snow through the clouds, but this is overloaded from clouds. Okay. Yes, thank you. Exactly. It's the typical cyan color, and the same color is also for the ice clouds, for the fronts, or for thunderstorms, but you find the right places. So I have here now the 24-hour microphysics cloud RGB for yesterday and today. It's one moment, the loop is loading. Needs some seconds. I hope it runs. Sometimes little problems. But you see in the southern part the pinkish color, and this is a strong dust outbreak from Africa to Spain, in relation with this clouds and the low pressure. I don't think it's. Yeah, there are some problems. I see. Okay, I have more loops, and I think this is a very helpful image, RGB image, because you can see the different clouds in the high, in the middle, and in the low part of the troposphere. So the reddish colors, the high clouds, the more brownish colors you see here between are the medium colors in the middle part, mixed colors, water or ice clouds, and the bright color, nearly green, yellow. This is low clouds, stratus clouds, stratocumulus clouds. So this is very, very helpful with a good contrast between the different clouds. There are only integrated infrared channels 12, 0, 10, 8, and 8, 7. These three channels are integrated in this. And so here you see the air mass RGB and the isotux from yesterday, 12 UTC, and we had in the frontal zone strong winds, and this was you see here a lot of clouds, lee clouds, mostly in Scotland, in the Northern Sea, in the leewards, or in the Norwegian mountains. And we had some signals for strong turbulence, or for severe mountain waves up to 6,000 meters yesterday. So the wind speeds are not extreme high, but the lee cloudiness are very strong. I will show you more in the next slide. I hope this loop is now running. Yeah, okay. So you see here nicely the big lee cloudiness in a bluish color. This is the HRV cloud RGB, and the bluish color is a sign for more thin ice clouds. And I repeat this, it's only a short loop. So you see here the line where the cloudiness starts at the mountains and spread over the whole Northern Sea. But there are always also a lot of lee waves in Ireland, England, or whole Great Britain. These are in the yellow color. This is a sign for mostly low clouds or middle high clouds. Here you see the interesting pattern, interesting structure of the sea clouds in different directions, where the local winds are formed, and it's interesting. I looked exactly. It's around about 150 kilometers on the water side, in the leewards from the mountains. You see here also, I think, 10 lee wave banks, one after the other. So it's a very stable situation, and I think it's interesting. So then we make a big jump to Africa, to the continent, and I asked you, this is a very important area for dust source. Do you know something in this image? Perhaps you can write it there. Do you know some mountains or some lakes or some names of an area? This is an image from I think NOAA satellite with the WIRS instrument, and I show you. This is the biggest dust source in the world. You see here a dust outbreak, the brightest color, and so these are here two mountains, 3 kilometers, Kibesti or Enidi, not so high, and you see also in the sand the structures from many years. They are formed from the trade winds, and this is called Modele depression. I think we have in the year 100 days with dust outbreaks, also the last days and yesterday. And yeah, you see in the southern part in Chad, is this all the lake Chad, and this lake was a big lake many years before, and so the rest of the lake is the sand and the sediments, and they are so fine that the strong winds blow them up. I think this is a big source of mineral source for the Caribbean islands, and the dust, yeah, you know, it goes over the Atlantic. So these are two images. It's now from the so-called dust RGB, and during day, the left image here, you see the typical color for the dust, the pinkish color, and in the night time on 2 UTC in the left image, so it's the colors are not so bright, and yeah. And why? What do you need for such an outbreak? You need wind shear. One, for the first time, you need wind shear of wind speed, and you need also a shear of wind direction. And if both comes together, then the dust will blow up, and the small will take away thousands of kilometers, around about 10 micrometers, only the small dust particles. So, and this is a dust outbreak from Africa. Now the loop is running, very good. This is the dust RGB again, and you see the 2 dust outbreaks. Now they come the next one, also a soup of a lot of dust, and it's involved in the clouds, and is now moving in the direction of Spain, and will change, the dust will change the cloud microphysics in this big cold clouds then. So, and the last image is Meteosat natural color again, and I looked to this dust situation yesterday in the evening. On the left side, you see here the Meteosat 8 over the Indian Ocean, position around about 40 degrees east, and because this satellite has a very slant view to the dust if the sun is go down in the evening, and we have a strong forward scattering in the dust, so you see the dust in the evening very good. Here about southern of France, there is the borderline. In Meteosat 11, it is not so good visible because the position of the satellite is another 0 degrees, and so you can use different satellites to detect the dust in a better way. So the rest of the clouds, I think it's clear. You have the water clouds in whitish color, and the vegetation in green, and so on. Okay, so this was my short view about through actual images. So, and now I give the part or the ball to Michael in Hamburg.
Yes, hello everybody, this afternoon. I will give you a different interpretation of during that session now. And my name is Michael Knobelsdorf, and I'm working in the Hamburg office, and I'm a forecaster of the operational branch, and I am also involved to be onboard meteorologist, and as well I'm working occasionally at the German Antarctic Neumayer station. And for this specific talk, I will present you something where we did some consultation for the research vessel METEOR, which was consulted from Hamburg. And by the way, that's me near the Normal station. And so this expedition, METEOR M170, started in Emden, as you can see here on the right-hand side, and then going to the English Channel, and then down to the Azores, and there you can see a change of itinerary, and that is something we will have a look at in terms of weather. And the whole expedition took place from the 11th of January until the 10th of February this year. And this is a photo of that research vessel. And the outline I have already said something about. We basically focus on the weather pattern between the 27th and the 31st of January. And just by coincidence, I figured out that just during that specific time, a so-called rapid cyclogenesis took place, and which was related to the storm low or even hurricane force low Justine, which was named by the Portuguese Meteorological Service. And therefore, I will also put some, well, just only a little bit of theory from the conceptual model about rapid cyclogenesis, illustrated in the example of that hurricane force low. And I will show you something through the EUMeTrain page. Okay. This should run. Yeah, it's running. It's the synoptical situation during that particular time period, as you can see, from the 27th, 12 that to the 31st of January, 12 that. And here you can see that low Justine, which actually developed at the east coast of the United States, about the 26th already here, and it started at 40 degrees north and went through the Atlantic, as you can see. And the most important part with that was a pressure drop within 24 hours, just by almost 24 hectopascal over the Atlantic, which is a sign that rapid cyclogenesis is taking place, as you can see with that Justine. Later on, it was heading towards Europe, and later it decayed. Okay, so just to give you a rough idea, and the meteor was somewhere between here, close to the Azores. And here we have another loop based on the same time frame, starting from the 27th of January, 18Z to 29th of January, 10Z. And here you can brilliantly see the rapid cyclogenesis just only by that image. You see the different color phases, and here you can see that it was later on then working through the Ireland, and it still has had pressure about 980 about the 30th of January over French Brittany, and then it disappeared over the continent. Okay, that gives you a rough idea about the whole situation. Here I have picked up the surface pressure from the 27th to the 29th, as you can see in the headline, and the left-hand slide is showing the synoptical pressure from the Spanish Met Office, by the way, because they are covering the Atlantic. And here on the 28th at midnight, you can see Justine developing and deepening further, and on this image in the bottom left side, and then it reached basically Its lowest pressure on the 29th of January, where you can see the tight isobars already, which means a lot of wind or even storm, hurricane force winds, and associated with that also quite a lot of waves. Okay, here I have something. I have actually picked up a special flight during the whole time period. This was the 28th of January, 12 back, the Airbus RGB, where I actually put the surface pressure on top, and you can see the low over here. And the question now for you guys is to figure out where the jet stream, where you find the jet stream. Okay. Just let me have a look. Allow to annotate. Okay, can you draw something in or not?
Not yet, not yet.
Ah, yeah, now, okay. That's okay. Yes. Yeah, I think it's pretty obvious. So who put that in here? You can see it already. I stopped that one already. And this was picked up from the portal, and you can see the jet here around that, and it's basically splitting the different air masses. You have the warm air mass to the right, to the Azores, high tropopause, the greenish color, the reddish colors, and number 2 is associated with high cloud. And here in number 3, you have the dry descending stratospheric air, which was basically related to that very strong developing low pressure system. As I already said, this was set up for the 29th of January at 00 set, and the naming is everywhere different. Not everywhere, but it's different. So the Germans named that one Peter, and the Spanish and Portuguese meteorological services named it Justine. So just to let you know that you're not confused when you are hearing something about Justine. And now we come to the forecasting part. This was actually the run for Monday the 25th for Thursday. And you can see here a red cross where the Meteor was operating. And this was the forecast for 12 set. And here was that low pressure system. And you can see the pressure pattern is the lines you can see here, pressure pattern from the most important models like ICON, ECMWF, GFS. And you can also see the weather pattern. There were a lot of thunderstorms in the area. And so that was the forecast on Monday. And then the scientific chief and the captain decided, well, we can't cope with that weather, we must do something about it. And this is the next more enhanced picture about the wind pattern, same run as you can see in the headline 25th for the 28th, 12th that. And you can see the wind bars in knots, and you can see almost 40, 45 knots close to the operational area, or even more here in this area, where we have also got the wave pattern with that legend, as you can see, and that color. So the reddish, or the red one, was associated with 4 to 6 meters, and that's almost the edge for the Meteor to operate with. So they were just looking at any alternative, what to do. And then that's our task, what we are fulfilling here in Hamburg. We have a special developed software, which is called MetMaster, and we can set up time series, and these time series were set up for the operational part for the Meteor, which was almost that area. on Monday and Tuesday for the Thursday. And what you can see is just on the top end, you can see the weather pattern in relation to the time setup. Just on the x-axis, you see the days and the time stamps. And on the y-axis, you can see a significant wave height, which is just the grayish color, as you can see here, and then split it up in wind, sea, and swell. And what you can also see immediately here for the nearest run, it was almost 6 to 7 meters for significant wave height, which is almost impossible for Meteor to operate with wind in gusts up to 62, which is really hurricane force winds in that time frame. And so what to do? On Tuesday, the 26th, we decided an alternative route. So the Meteor was operating in that area, and we decided that Meteor should go south. And when you recall the previous slides, there was a little bit less wind. And so we were following up that alternate route to the south and then a little bit northwestward back to the original area. And in the last, in this image here, you can actually see the route from the beginning towards the end of that alternate route. And again, upper part, you can see the wind speed in the relevant time frame, and the red color is giving you an indication about the wind. And with that alternate route, it was possible to manage a sea state of about 6 meters, which was just very close for operation, but it was just a little bit better than the original plan. And so they decided to do that. And to give you an idea of what we are doing, when you go on that link, which I just touched, you can see the marine weather consultation, what we're doing worldwide. I don't want to go into details, just for any route consultation. You can see an example here. Here you have the sea height, and the bluish color is just the orientation of the ship. Anyway, so this is just an example how we operate, and coming back to that. And now we go into more detail for that specific time period, 28th of January, 29th of January, with the surface pressure pattern from the Spanish Met Office and the air mass RGB accordingly. At the same time, you can see the surface pressure and the air mass RGB on the lower part. And I don't want to go into full detail, but just to show you where you can find that all on EUMeTrain. You have two options to either go to the ePort or to the ePort Pro. And just when you go in here, you have, well, this is the current pattern. You have variables regarding the models, which you can select, and all different satellite products where you can select as well. And on the upper part, you can open a calendar where you can actually set up a special time in the past. So it's a sort of archive, and that's what I was using. And this was basically the overview about that. And okay. And now I pick some features for some key parameters for the rapid cyclogenesis. And I will show you an example here for the 27th 2100 Z. And just here it was measured afterwards, of course, between the 27th and the 28th, the pressure dropped with that system about almost 24 hectopascal. And this is one of the major features just in the system is deepening in that speed. It's related to rapid cyclogenesis. So you can actually see a stronger warm advection. You can see a clear dry time, what we have already figured out, dry intrusion. And later on, you will see the cloud spill in the later stage and quite rising cold conveyor belt with the cloud head forming up, and later on the spill. So again, I picked something up from the EUMeTrain portal, and as you can see, the 28th of January I took for the 12 bed one, just to get an idea about the potential vorticity, which I selected here on the left-hand side, the height in hectopascal, potential vorticity 1.5. And here you have longitude and latitude. And here you can very brilliantly see the situation where you have the maximum of the potential vorticity just close to the cloud head. And again, you can see in the 300 hectopascal isotech the wind speed, which is also located here on the right axis of the jet stream in the cloud head, where I put a smaller image here. And the next slide will show something about the temperature advection at 700 hectopascal. You see the surface pressure overlaid with the next parameter of the temperature advection at 700 hectopascal. And you see a quite strong signal near close to the cloud head with strong temperature advection. And the same you can apply for the cyclonic vorticity advection, which means there is a rapid pressure developing, a drop in pressure developing. And in combination with the surface pressure and the air mass RGB, and on top the water vapor image 6.2, you can brilliantly see the dry intrusion, which can be clearly seen by the dark area on the rear side of the cyclone, caused by the jet streak. And well, the previous one you saw the yellow isolates for the wind speed. Again, this is very clear and obvious that there's something happening. And the next following slide, I will show you the other part of the EUMeTrain portal, which is the second one, the ePort Pro, and that's both portals have different approaches, and you can benefit from both of them. Just while we are here, you have a timestamp here where you can select a date, which is now set on the actual phase. And on the left-hand side, you can select the sea level, the different images, and the forecast products for the different instruments on the satellite. And then, of course, you can also choose from different parameters, what I already mentioned, like isotechs, for instance, and potential vorticity height or whatever. And you can select that easily. And on the left-hand side, you can either choose favorites, or you can even do cross-section, where you can actually set up an air mass, and you can move through certain air mass, and you can see about some developments taking place. on top of that, you can also select upper air profiles like temps or whatever. Anyway, so that's what I used. And here we have again the timestamp on the lower bottom here. You can see the 29th of January at 0 sec. You can see Justine here well defined, and you can see the dark area on the rear side of the cyclone. Here you have latitude and longitude. And next slide shows you the overlay of the surface pressure, well defined. You can see the low here, just in very good combination with the water vapor image. And another thing which is quite challenging is the derived SEAWIND data from the ASCAT instrument on the satellite, which I also got from the portal. However, when you see on that image, it's quite confusing. You see various colors, and the magenta color is just showing you some very strong winds. And I enhanced that, and now you can see either the low here, and you can even see for very strong winds like 50, 60 knots here in that area, and some easterly winds about 40 knots just north of that low. And so that gives you an indication that there were really very strong winds involved with that low. Okay, and this is a forecast product from the ECMWF model about the significant wave height, and that was the run from the 28th of January. And at this point, you can see the original planned operational area of the Meteor, which is just marked here with the cross, BBH, and they were experiencing 4.5 meters according to the model, and the sea pressure about 1,008. And as this system was approaching for the next timestamp, you can see the significant wave height went up to almost 6 meters, and that's one of the reasons why they dropped a little bit to the south. And it's just a very, very tactical strategy, as you can see. Just that as they went down a little bit south, they were not in the strongest wave pattern, so they could at least do some experiments during that time. And this one was then the situation for the 29th, which we have highlighted here on the lower part of that slide. And you can see there were still very strong or very high winds associated with that low, about 11 meters, heading towards Ireland, and they have experienced very strong swell and significant wave heights later on the month change. Another quite important slide, which was taken for our consideration, was the so-called extreme forecast index for wind gusts with a run from the 28th. And there you can see it was a very active season during that specific time. That was related to Justine. Just to keep in mind, if it's one, it's almost quite obvious that a strong event is happening. The less it gets, it's getting better. Here we have 0.4, which is showing that there almost is not much happening. And this was heading towards Ireland and towards the continent. And in the wake of that strong system, there was already another one following up which was actually quite an active season for operational tasks for the Meteor during that time period. However, due to our consultations, they were able to fulfill almost all their tasks, and the expedition finally ended in Emden, and they were quite happy that they at least were able to manage all the experiments. And this is something which they probably also experienced, but this photo is not taken from the Meteor, it was from the Polarstern, but they have had quite strong winds, and the vessel was shaked up quite a lot. Yeah, that's it from my part. And just to give you an overview about weather and forecasting and using EUMeTrain portal during our forecast period. Thank you.